So, what's up guys, this is me again, your resident round bottom flask, and welcome to the part 3 of the lecture series for the basic concepts of structure and bonding in the context of organic chemistry. So far, we have discussed in the parts 1 and 2 of our lecture series. Lewis structures are both convenient and accurate representations of the structure of molecules. Now let's go back to our example that we have shown in our part 1. So this organic molecule here, which is ethylene. Now, drawing its Lewis structure, it's pretty straightforward if we follow the rules that we have established on the part 1 of our video. So again, if this is your first time watching this video, I suggest you look for part 1 and part 2 of my lecture video series for basic concepts of structure and bonding, para sa sauce, or for context. So going back, so drawing the Lewis structure again is just pretty straightforward if you follow the rules, as I've said in our part 1. Sauce is on this channel. Just look for the part 1 and part 2 of this lecture videos. So in Lewis structure it's pretty straightforward. Okay, now it becomes more complicated when the organic molecule becomes large. So let's have this example here. Now this one is, wait, nagahang yung laptop ko. Oh god, nakakahiya. Ba't siya naghahang? Ayan. So, this is the chemical formula for oleic acid, which is the most common one of the most abundant fatty acids found in your palm and the canola oil. So, based on its chemical formula, it's a pretty large molecule, and if we draw its Lewis structure should look like this. Okay. Now, this drawing the Lewis structure of a molecule of this size is quite cumbersome, or rather, quite tedious to draw. So, organic chemists devise some shorthanded notations in representing structures of organic molecules. So one of those structural notations that are used is the condensed formulas. So condensed formulas, it's like an expanded version of your chemical formula, in such a way that it shows the hydrogen atoms and other atoms that are attached to the carbon, and they are usually written in the condensed formulas right next to the carbons where they are attached. So let's have an example of this organic molecule. So this is our ethanol, or our the alcohol found in beer and all alcoholic drinks. So this is its Lewis structure. If we convert that to our condensed formula, the condensed formula should look like this. Now, this carbon here represents this carbon here. So let's try to name this as carbon 1 and carbon 2. Now, this carbon here represents our carbon 1. And if you see, carbon 1 is attached to 3 hydrogen atoms and another carbon atom, which is carbon 2. And if we could look at the condensed structure, those 3 hydrogen atoms are written after you have written the symbol for carbon that represents carbon 1. So that means it is CH3. That means the subscript indicates how many atoms of that element is attached to this carbon preceding it, to the carbon preceding it. So if you can see this carbon, god, hindi gumagana yung ballpen ko. Ayan. So this carbon here is connected to 3 other hydrogen atoms as represented by its Lewis structure, and another carbon atom as represented by its Lewis structure. Now, this carbon atom is attached to two other hydrogen atoms and one oxygen atom. So this carbon atom here represents the carbon 2 in the Lewis structure of ethanol. And as you can see, carbon 2 in the Lewis structure is attached to two hydrogen atoms and one oxygen atom. So as you can see, the two hydrogen atoms, which is represented by this part, is written after you have written the carbon for carbon 2 in the condensed structure. Same goes with the oxygen attached to that carbon atom. And lastly, that oxygen atom is attached to one hydrogen atom. So therefore, anong tawag dito? So therefore, the hydrogen directly attached to oxygen is written after writing the oxygen atom. Now this is pretty straightforward for such a simple aliphatic compound such as or straight chain compound such as this. So what if we have this kind of Lewis structure na meron ng branching? So we write it in this way. Now obviously this carbon here is represented by this one. And how do we represent this carbon? Now this carbon here is attached to two other carbons, and those carbon atoms are attached to three other carbon atoms. So since pareha sila, what you do is you enclose this in parentheses. So this one represents the CH3 group, or rather the CH3 group attached to this carbon atom here. And since there are two of them, you enclose it in parentheses and you put subscript 2 indicating that there are two of this CH3 groups attached to this carbon here as indicated in our condensed structure. So after you've written this one here, punta na tayo dito sa carbon 2 after you've written this one here, you proceed to the next carbon. Now this carbon, or let's say this is our carbon 3, so this will be our carbon 3, is attached to two other hydrogen atoms and one carbon atom. So you write those two hydrogen atoms, which is denoted by H subscript 2, and then you write the other carbon atom after you have written the carbon for carbon 3. And then lastly, this last carbon atom is attached to three other hydrogen atoms. So you write it there, and then you write the hydrogen atoms and you write the subscript 3 indicating that there are three hydrogen atoms attached to this carbon here. Although condensed structures is convenient to the fact that you do not need to draw lines, however, this does not actually give a more accurate representation of the structure of an organic compound, unlike Lewis structures. And also, this kind of condensed structure, this kind of structural notation rather, is not applicable for compounds that have rings. So, for example, we have this compound here. So this compound is naphthalene, which is the active ingredient in our mothballs. So how can you make a condensed structure based on this formula na puro rings? Okay? Based on this Lewis structure na puro rings. So the more common structural notation used in organic chemistry is the skeletal structure. So the skeletal structure, skeletal formula, is like a short-handed version of the Lewis structure. However, the carbon and the hydrogen atoms are not shown as chemical symbols, and because they are not shown as chemical symbols, the carbon and hydrogen bonds are not shown. So let's going back to this Lewis structure. If we have this Lewis structure, this part here completely disappears in the skeletal formula. So what is left here is the CC, the non-CH bonds. So it would look like this in our skeletal formula. Now, the vertices, the starting points and the vertices of the line represents the carbon atoms, and this lines here represents a CX bond, wherein the X can be any atom except hydrogen. Okay, now if you have if the Lewis structure contains atoms apart from carbon and hydrogen, that's only the time when you write the chemical symbol for that atom. So for example, in this Lewis structure, since it has an OH group, you write the OH here. Okay, so since the hydrogen here is attached to the oxygen atom, this hydrogen does not, the symbol for hydrogen still appears in the skeletal formula. So let's have a branch compound. So let's have this Lewis structure. If we draw the skeletal formula, lahat ng CH bonds, lahat nito mawawala, at pati na rin yung chemical symbol. Actually, lahat ng to hindi this structure here, this groups here, this will not be shown in the chemical formula. What will be shown is the carbon-carbon bonds. So it would look like this. Okay, so to indicate one distinct carbon bond from the other, you draw some sort of broken lines like that. Okay, because this vertex here represents a carbon atom. This vertex here also represents a carbon atom. What do you call this? This end of the line here, this ends of the line here also represents carbon atoms. So your carbon atoms again are basically represented by vertices, or the beginning of end of the lines in the structural formula, or the skeletal and structural formula. And you count the number of carbon atoms based on the number of vertices and ends the skeletal formula has. So this skeletal formula has 2 vertices, 1, 2, and 1, 2, 3, 4, 4 endpoints of the line. So that means that is a total of 6. So this has 6 carbon atoms, which reflects to the Lewis structure, which also has 1, 2, 3, 4, 5, 6 carbon atoms. So let's put our knowledge to the test. So we have a Lewis structure, we draw the condensed formula, then we write the skeletal formula. So this one here, this is pretty straightforward. If we draw the condensed formula, this is a CH3 group, so we write that down. Then after that, this is a CH2 group. However, how do you write this group here, the C double bond O? Now in the condensed formula, the C double bond O, it's just simply written as CO. Okay, that is it is automatically known that that is C double bond O. Okay, and then this group here obviously will be our CH3. Now we based our skeletal, we draw our skeletal formula rather based on the Lewis structure. So it will be, this carbon atom will represent the starting point of a line. Then we draw a straight line from a straight diagonal line from that. So this end line here represents another carbon atom. Since it is connected to another carbon atom, you draw another diagonal straight line here. So we do it this way so that we distinguish that this vertex is a different carbon atom. Kasi kung dediretsahin natin yan, na parang ganito, it would look like that there are 2 carbon atoms that we have drawn so far instead of 3. So we do it like this, like a what do you call this? Like a zigzag, in a zigzag manner. Then this one here represents a carbon atom. So oops, sorry. Oh, why this is not getting erased? Ano ba yan? Naglalag na naman yung laptop ko. Sorry guys, I don't know what's happening to my laptop. I think because I've been using it all day and it's a sign that it needs to rest. So again, going back, so we draw this one here for the 3rd carbon atom, then we draw another line here for the 4th carbon atom. And since this one here, for the 1st, 2nd, and 4th carbon atoms, it's only connected to hydrogen atom, so we don't show that here in our skeletal formula. However, in the 3rd carbon atom from the left, it forms a double bond with an oxygen atom, so we have to indicate that in our skeletal formula. So we draw a double bond here in this vertex here, and we write the oxygen atom there above the double line. So this part here represents the CO double bond shown in the Lewis structure and in the condensed formula. So let's do this another way around, wherein we have the condensed formula, then we draw the Lewis structure. So this is quite challenging, and it takes practice for you to get the hang of it. So let's have this condensed formula here. Let's try drawing the skeletal formula first. So we have a CH3 and a CH group here, so that means we have 2 carbon atoms connected together, and we draw that by using a single line. Then we have a CH3 enclosed in parentheses, then preceded by CO2. So what does that mean? This carbon atom is this CH3 group is connected to this carbon atom, but not connected with this carbon atom. So that means we will have some sort of branching here. So we have this carbon atom connected to this carbon atom, so we draw that line there, and we have this CH3 group connected to this carbon atom, so we draw that line here. After that, we draw this carbon atom. So we have CO2. So what does that mean? It means there are 2 oxygen atoms bonded to it. Now, obviously, it does not complete its octet. So that means in order for this carbon to complete its octet, one of the oxygen atoms should be doubly bonded. So let's say, so that means we have a doubly bonded oxygen and a singly bonded oxygen bonded to this carbon right here. So this carbon right here is this one. Okay. Next is that we have a CH3 group here. So where is that CH3 group connected? It is connected to one of the oxygen atoms, so particularly to that singly bonded oxygen atom connected to this CO2 group here. So this is I'm referring to this oxygen since single bond lang siya sa carbon na ito. So we draw that line here, and this one will represent the last CH3 group. So this will be the skeletal formula for this compound. So from the skeletal formula, it's easier to draw the Lewis structure. What you just need to do is draw the carbons, what do you call this? You write out the chemical symbol for carbon, and you show the hydrogen atoms connected. So based on the condensed formula and on the skeletal formula, so you have carbon atom connected to 3 other hydrogen atoms, and we have another carbon atom connected to 1 hydrogen atom and connected to another CH3 group, and this carbon atom, this one here, which is also this one here, in our Lewis structure is connected to the CO2 group. So C double bond O, single bond O, and this last CH3 group is connected to the singly bonded oxygen of the CO2 group. So this will be the Lewis structure. Now, next is we have this example here, the skeletal formula. So from the skeletal formula, again, you just show the carbon, you just spell out the carbons and the hydrogens there. Now, how do we know how many hydrogens do we need to add in our Lewis structure based on the skeletal formula? So the technique here is that, remember that carbon should have 4 bonds, okay? Now, if there are missing bonds there in the skeletal formula for the carbon, that means those missing bonds are actually CH bonds. So let's have this carbon here. So it has 2 missing bonds. So that means it is connected to 2 other hydrogen atoms. Then we draw the double bond here in our Lewis structure. Then we proceed to this carbon atom, which is this one, and since it only lacks 1 bond, so it is connected to only 1 hydrogen atom, then it is connected to another carbon atom, which lacks 2 bonds, so that means it has 2 hydrogen atoms, which is connected again to another carbon atom that is also connected to 2 hydrogen atoms, and this carbon atom here is doubly bonded to an oxygen atom and singly bonded to another oxygen atom. Since it has complete 4 bonds, no need to add hydrogens there. So C double bond O, then we write the oxygen here, which is also connected to H. So what will be its condensed formula? Simple, you just condense this one here. So this is again a CH2 group, and this is just a CH group. This is a CH2 group, another CH2 group, and lastly this is a CO2 group. But since that one of the oxygen is connected to hydrogen, so we write the H after writing the O2 in the CO2 group. So this will be the condensed formulas. So once again, guys, thank you for watching this video. I hope you get the hang on writing the shorthand notations for writing chemical formulas. So if you have any questions, don't forget to place it on the comment section of the YouTube channel, or you can DM me in my email. And once again, this is your resident round bottom flats signing off. Don't forget to subscribe to this channel for more videos and more tutorials in chemistry. So that's it. See you guys.